Ooh, don't you just love a lesson with the name Decomposition in it? But I don't want to ruin the joke I've got coming up because I've worked really hard on this joke. But welcome today to the lesson on prime decomposition. All right, those of you who are being taught by me at this moment in time, there is the work that I would very much like you to be able to do by the end of my teaching. If you are watching in internet land, welcome. Hopefully this explanation will help you do brilliantly in mathematics. All right, so what is life all about? Well, a recap's always good, isn't it? So in a previous video or lesson, we've looked at the idea of prime numbers, composite numbers, and powers, right? And so now, because maths is awesome, we don't just teach one concept and then just sort of put it in a box and slide it back to the back of our head and go, yep, done, thanks very much, never using that again. We actually start to link them all together. So having done that, we've also looked at lowest common multiple and highest common factors. And we did factor trees and some really interesting mathematics. Well, now, ladies and gentlemen, we are going back in time. Funky graphic. Let's go back to this prime decomposition. When I see the word prime decomposition or in decomposition, I think of The Walking Dead. Now, not that any of you below the age of 18 should be watching The Walking Dead. It is pretty scary. It is pretty fairly full on. And Neelix, I have to say, is really quite mentally just not good. But I always think of the idea of these zombies and decomposition. But thankfully, with mathematics, we have nothing to do with decomposing bodies. Do you like my picture here of my little zombie? All right, not at all scary. But if he ended up in a zombie apocalypse, I'd be really worried. Anyway, however, the word decompose means to break down into small parts. So when we unfortunately pass away and we're buried, then what actually happens is our body starts to break down and becomes sort of part of the world around me, really. And it sort of breaks down into its small parts. It would be rather depressing if we all stayed in our same form. We'd probably run out of space pretty quickly. But now let's look at what the English tells us. Remember, with maths, English is really helpful. It tends to give us a hint. If we understand, right, what English means, then maths should be a lot easier. So prime decomposition means breaking a number down into its smallest parts by using prime numbers. So here is an example. And if you've watched my previous videos, you will already know that we've been doing this. So the number 72, and I'll just do it beside again, can be broken down. We're always looking, when we split it up into two, of two numbers that multiply to give 72. As you can see, I've used the number 2. I always like to half a number where I can. Because 72 is even, then it's quite easy for me to be able to keep halving these numbers in my head. So 2 and 36. And whenever I get a prime number, I put a circle around it. 36 is even, so it divides by 2. So 2 and 18, because 2 times 18 gives me 36. 18 can be split up into 2 times 9. Right, again, 2, put a circle around it, and 9 is not an even number, so it can be divided by 3. That doesn't mean that all odd numbers can be divided by 3, by the way, but I know that 9 is 3 times 3. And there we go. I can't go any further. And so, as we've said here, that means we can write the number 72 in a different form. We can write that 72 is 2 times 2 times 2 times 3 times 3. Why? Well, look at the numbers at the end of each of the columns. 2 times 2 times 2 times 3 times 3. And if we just backtrack it and just check, does 2 times 2 times 2 times 3 times 3 give me 72? Well, 2 times 2 times 2 times 3 times 3. 2 2s are 4 times 2 times 3 times 3. I'm breaking my problem down into sections. 4 times 2 is 8 times 3 times 3. 8 times 3 is 8, 16, 24 times 3. And 24 times 3 is, in fact, 72. So you have to ask, why are we doing this, right? It seems a really long way to write a number. Well, if you remember from our previous video, we can actually now group numbers by using powers. How? Well, if we remember that 2 times 2 can be expressed as 2 to the floaty 2, and 2 times 2 times 2 can be expressed as 2 to the floaty 3, that means I can change this 2 times 2 times 2 to become 2 to the floaty 3. And this 3 times 3, using power notation, 3 times 3 can be written as 3 to the floaty 2, and that's where the 3 to the floaty 2 is. Remember, this times in the middle, and that times in the middle must stay. Although you could, if you remember, write that as 2 to the floaty 3, 3 to the floaty 2, but that looks way confusing. And so generally speaking, we put the times in just to make it easier. So that is using the prime decomposition. But so powers are a quick and easy way for us to write a lot of multiplications in a simpler way. There are rules to the powers and some of them are really funky, but for now you need to know that a number, the base, written to a power, so 3 to the floaty 2. This one here is called the base, and this one here is called the power, or the index, or for me, the floaty number, because it's a number what floats. Right? Basically means, so 3 to the floaty 2 is the same as saying 3 times 3. This 2 tells you how many times to write it. So if I had 6 to the floaty 3, that's the same as 6 times 6 times 6. That floaty 3 tells you to write the base number, this big number, 3 times and put times just between it. So here are some power examples with a little power graphic. Oh, I wake up early in the morning to think of this stuff. So let's just check. X to the floaty 2. Now you're going to go, hold on a moment, where's my numbers? Where's my numbers? All right. Well, it doesn't actually have to be numbers. We can still use letters. And this was the first lesson I had to do way back in, well, it was called first year when I was in the United Kingdom. That was our very first lesson. Over here in Australia, you don't really do this until year 9 to year 10. So, wow, I had it hard. So, x squared. Remember, x squared. There's my base. And this tells me how many times to write it with the times in between. X cubed. There's my base. That's how many times to write it. X times X times X. And as we can see here, even when we change the letter to a B, the floaty 5 tells me to write it 5 times. Right? So the base number is the big number. And we can string lots of powers together like this. And as we just seen with prime decomposition, a cubed times b squared times c is exactly the same. Well, a cubed, remember, is a times a times a. There we go. Times b squared, which is b times b, times, don't forget the times is c. That's where we get. Now that's called expanded form. And questions in maths will ask you to do expanded form. That means just write it out long ways. But if you have it written in this first form here, as I've said, it is called index notation. Right? So index, indice, floaty number. Unfortunately, no one yet has come up with the idea of calling it floaty number notation, but there's always hope. So, then we get to the idea of floaty numbers and other stuff. Now, don't you just hate the English language? The fact that we have so many different ways of saying hello and describing one thing. I mean, if you think about like when we times things, well, we have product and multiply and times, and all these things mean the same. And I'm sure there's others. But yeah, I think there's a guy in an office somewhere who basically goes, I think we'll just make up lots of words that mean the same thing and really confuse kids for maths, yeah? Because we really want maths to come over as complicated. So, here's a question. Find the product of the primes of 80. Product. Now, here we go. This is where the wording confuses. Product means to multiply or times. Primes means prime numbers of 80. So, we now know that we are effectively doing prime decomposition. That product of the primes is exactly the same as prime decomposition. Oh, decomposition. Thank you very much. And so all that means is here's my 80, split it up into 2 and 40, split it up into 2 and 20, 2 and 10, and then 2 and 5. And because they is all prime numbers, then I can now re-express 80 as 2 times 2 times 2 times 2 times 5. Remember, that's in expanded notation or expanded form. And if I wanted to write it in index notation, well, I've got 2 to the power of 4 times by 5. And you could write 5 to the power of 1 if you wanted to, but generally speaking, we don't need to. And there's my answer. Ladies and gentlemen, this was a lesson on prime decomposition. Thanks very much for listening. I look forward to seeing you in my next video. It's been so great having you watch this video that I'd like to see you again and again and again. Wow, we could make some amazing maths together. So, if you'd like to, and you'd like to be updated as to when I upload new videos, why not subscribe by clicking the button on the right? Otherwise, if you want to click and see another video created for this type of series, then click the video on the left. Alright, well, you have an awesome day, and I look forward to see you again.